This is our second video on section 1.5. It is another example of your homework number 7. In this one, I've actually taken some problems like the ones you'll have in homework, and I think this might help you to understand their questions a little better. They give you a graph here, and again I'm going to say if you actually print this out from your notes, it might help you. Some of my graphs may be a little hard to read, but if you have it in front of you, it'll make it easier. We're going to use this graph given to us, and we're going to find the interval of increase, the interval of decrease, and the interval of constancy. Well, when you first look, this graph is decreasing, constant, and increasing. But remember, we said we always start at negative infinity, we go to positive infinity, and we're always looking for these x values where this changes. So I'm going to go ahead and mark those. Now, my first, it says which interval are we increasing? Well, this is decrease, this is constant. Here is increase, and that's going to be from 3 to positive infinity. Now, be careful that you mark A with parentheses. Increase, decrease, constant intervals are always marked with parentheses. Second, it says where is it constant? Well, that would be between negative 3 and positive 3, but again with parentheses. Where is it decreasing? Well, it was decreasing right at the first, and that was from negative infinity over to negative 3, but again with parentheses. You remember increase, decrease, always use x and always use parentheses. Number 2, now we're going to back and think of domain and range. We did this in an earlier section, so this will be a reminder. Choose the correct domain. Now remember, domain and range may use bracket if you actually touch the point, parentheses if you don't. Domain, remember, is horizontal, right and left. So I go as far to the left as this point, which is negative 8, and as far to the right as this point, which is positive 8. Domain, remember, is x. So I'm going from negative 8 to positive 8. But on this graph, if you'll notice, right in this little section between 2 and 3, there's no graph. So I have to break it. My domain is from negative 8, inclusive, over to 2, and then I have a break, and I pick back up at 3 and go to positive 8. So that's going to be B. Find the correct range. That's high and low. Remember, that's Y. I'm going to go as high as this point, which is 7, and as low as this point, which is negative 7. And I touch that point, I touch that point. That's going to be C, negative 7 to positive 7. Alright, problem 3, they talk about relative extrema, and this is just, if you'll notice this graph, we have a low point here, which is a minimum, a high point, which is a maximum, and we have a second low point. That's not the lowest point on the graph, remember. That's why they call it relative. That's when you can have several. If you have hills and valleys, you may have several maximums, several minimums. On this graph, we have some decimal x's and y's, so they've actually given us the values. We couldn't read the graph correctly if they hadn't. Given this graph, does the function have a relative maximum or minimum? This graph goes up to a high and then down. So this point is a high point, it's a maximum point. Alright, next, it says the relative maximum occurs at what x? And this is where this is so useful. They told us what x. The x of the high point is 5.5 and has a value of, that means the y, is at 7.25. On what interval is the function increases? Well, remember, from negative to positive infinity, it first increases to that x value that they give us, which is negative infinity to 5.5. Where is it decreasing? Well, it decreases from that same x value, 5.5, to positive infinity. You must remember, with increase, decrease, you're using x values and you're always using parentheses. We have an application problem. Yardbird Landscaping has 46 meters of fencing with which to enclose a rectangular garden. Here's where a picture is so valuable. Here's my rectangle. If the garden is X meters long, express the area as a function of length. Well, if this is X, remember I have to go all the way around this garden, all the way around, using only 46 meters of fencing. So let's say that this is going to be, let's just call it Y. That 46 is our perimeter. If you remember, perimeter is all around X plus Y plus X plus Y, and we know that perimeter is 46, and that's 2X plus 2Y. Now I have a 2 in all of these, so I'm going to divide by 2, so it'll be 23 equals X plus Y. Now, they want us now to talk about area, and if you remember, area is length times width. And they want us to talk about this in terms of length, but they have called this length, if you'll notice, X. We might want to go up here and say that it's X times Y. Now, if I want this expressed as length, and you notice they're using variable X, all that's saying is that instead of X times Y, I want X times Y expressed in terms of X. So what I'm going to do is go right back up to this problem, and I'm going to solve for Y by moving this X over. So that would be 23 minus X. Now that means my area is X times not Y, but now 23 minus X. That's all they're saying. Express this in terms of one variable, and they've told you which variable. They want X. So if this is my area, then that would be if I distribute 23x minus x squared. Now you go over and find that expression written in function notation, and here it is, 23x minus x squared, and it's written as a function a of x.